example, we've got the motion trails, which is brilliant. We're actually probably wanting to put it into Unity physics, but it shows you the motion over time. You can start to see some of the pieces there deactivating and going green, although obviously at the moment a lot of them are active and representing in blue. You've also got the performance metrics, which dig down and show you information quite like the profiler in Unity itself. And you can actually, inside the visual debugger, pick up bodies, move them around, and they will update on your game as well or in the editor. So there is an actual two-way interaction there as well. One of the particular visualizers I want to highlight is the heat map. We're finding a lot of use cases where both the designers as well as the programmers are finding this useful. This is basically highlighting graphically where the CPU load for the simulation is in space. And it's quite nice to see the sort of heat map expand as you start piling on bodies on top of each other in that previous 12,000 convex hull demo. So sort of a little pause and show some real game use cases where they have sent in their visual debugger information for us to look at and try and help them debug a particular problem in the physics world. So there's a little bit of customization the guys have done here. You can see in the bottom corner, this is they're using a pencil type shape for the character controller, which is interesting. They're actually drawing the camera view frustum as well, in those sort of cyan colored rays. Obviously there's a large explosion there, and they were drawing the forces that they were applying on the objects. And these are some of the vehicles, obviously, well, maybe it's not obvious. But can anyone name the game? Haha, well done. I wish I had like a t-shirt gun I could send out swag. So that's the same sort of scenario, only with the large amounts of particle effects added into the scene. The explosions do make a bit of a difference. But I could watch that all day. So here's another example, again, when we're talking about the vehicle use case. You can see that lots of debris pieces are flying out, but the road itself has the odd bump, but it's mostly smooth. We're seeing the broad phase in the world here. We're also seeing constraints being represented on some of the bodies previously. And as this goes through, you start seeing these red boxes are trigger volumes, so the car actually drives through them, but we can visually see where the trigger boxes are. Anybody know this game? It's a bit hard to guess, but... Sorry? Uncharted? I do have a VDB movie of that, but I'm not allowed to show it. No, this is MotorStorm Apocalypse. So you can just see that, again, the graphical, sometimes there's a disconnect between the graphics and the physics. Here the road has got a lot of debris pieces on it, but none of those are being simulated, because that would make a horrible driving experience. But hopefully you can see how the actual gameplay mechanics are all represented in the physics world. Okay, I've got one final one, a different use case again. This is interesting because the red boxes are supposed to be axis aligned, but obviously they're not on the canonical X, Y, Z axes. So in this particular case, we're standing on a planet about where Spain would be. Can anybody guess the game? Well done. So I believe this is the actual planet that they were going down onto, because you can see those sort of spiked curve structures whenever the spaceship lands. So it's very interesting that those game developers are sending us the visual information, and we can help debug the sort of scenarios just from that physics information itself. And also in being able to visualize that immediately lets you see specific problems, like the planet being a box rather than a sphere. Okay, so just want to summarize the sort of core differences, and hopefully this isn't just marketing speak, it's just to give you information. So we are using the same data, we are getting better performance, we are getting better behavior, or behavior that you can opt into if you want. And all of this technology and all of the core underlying Havoc simulation is definitely battle hardened, and some of the games that are using it we saw directly there. And this is available now in the package manager. Please go grab it, and please give us feedback on the forum on what your experiences are. The package that's on the package manager at the minute is fully functional. It's currently a trial package just to start giving the community access to this and to get feedback from all you guys. And that trial sort of ends on the 15th of January next year. That's obviously a point before that we will release the final package, which is going to be free for Unity Professional and Plus users, and $20 a seat for Pro users a month. So there's a lot of stuff in the Havok Physics SDK that isn't maybe necessarily represented in the component data interface at the moment. And I just want to show some of the things that are in Havok Physics that we could enhance the Havok Physics offering more with these features. One of them is convex decomposition. The SDK at the minute is providing simplification of convex objects into convex hulls. It's dealing with data that's very noisy and still producing convex hulls that are quite good. It's producing unstable cows and horses. The use case is a little bit less common, but it can break down sort of static environment into sort of a series of convex hulls based on the level of detail you want. Another option is optional penetration recovery. This is useful if the designers are wanting to put a specific stack of dynamic objects in the scene, but they don't necessarily want to line them up perfectly, so you don't get that sort of initial, hopefully we've all seen that, where a stack of boxes just sort of have to settle and move a little bit. But we can turn that off, and we can ignore certain contact points that stop objects going further into penetrative state, but allows them to come apart. Again, useful for that sort of explosion use case, or just means that the designers can be a little bit more lenient when they're placing dynamic objects around the scene. Havok Physics has also got a much more accurate aerodynamic model, if that's needed, and a buoyancy system there as well, although the boat attack demo that you can see on the stage with the universal render, they have been playing with doing the buoyancy in dots already, which is quite interesting. And there's also a pretty big piece in the Havok Physics SDK. Haven't worked a good name out for it, but lower fidelity rigid bodies is a reasonable term. This might mean that we could have something. We've had physics collider as a component, we've got physics mass, we've got physics velocity. We could have a physics quality component. Now, that particular component might not do anything with the Unity physics backend, but it could actually use the lower fidelity rigid bodies that are available in Havok Physics. And you're getting, on top of Havok Physics, you're getting another 8 times CPU performance increase. And here's some examples. So that worst case scenario of piling 12,000 bodies on the surface, it now becomes possible with the sort of performance you can get from these lower fidelity rigid bodies. And it's not just, well actually, this particular scene at the bottom was that we're shooting up bodies, that we're showing the difference between what would happen if you used a full fat rigid body, full fat, is that the right term, or the low fidelity version, and you can see the sort of performance graph on the bottom and see what the differences are there. They're not going to be as accurate, they're not going to be perfectly stackable. There are going to be trade-offs, but they are going to be incredibly cheap. And you could have a 6-DOF version where you're having rolling boxes, and you can have an even simpler one that's just a 3-DOF particle, as the one in the top right. Here we're actually colliding with a full mesh geometry for every single particle there, but it's a 3-DOF version, so it's a lot more performant. So that is me. Hang around for questions after this. We are on the Expo Partners area and the Microsoft Game Stack booth.